Well, since the pizza isn't here, I'm just going to give you a preview. How do you do a determinant of a 3 by 3? Okay? Well, if you have a 3 by 3 matrix, then I'm just going to use asterisk for the various numbers. Each asterisk could stand for any number, right? Okay? I'm going to take this first number in the first row. Okay? And then I'm going to throw out that row and column in my mind. I'm going to keep the matrix there, and I'm going to do the determinant of this 2 by 2 matrix. Okay? You understand that that's really easy to do, right? Take the first number in this row, throw out that row and column, the matrix you got left over, you take its determinant, and you multiply it by this number. Okay? Now I'm saying it fast. If you hear it slow, that's really easy. Okay? Then you do the same thing for the second row. You take this number and you throw out its column and row, which leaves you these numbers here, right? Well, those numbers form a 2 by 2 matrix, and you can easily calculate their determinant, right? Okay? We see, if we take this number and throw out that column and row, we get 4 numbers that we can put into a matrix. And then this times this minus this times this, right? Then we multiply that by this number. And then we multiply that by -1. Okay? Then we do the same thing for this one. And of course we get this matrix here. So we multiply this number by this matrix. Okay? So we do it for this number. Then we do it for this number but multiply it by -1. Then we do it for this number. Now if we had a 4 by 4 matrix, we'd then go to the fourth number, right? Throw out its column and row and multiply this number by the determinant of this matrix and multiply that by -1. It's like we go this one, then minus this one, plus this one, minus this one, all the way across the row. Just alternate plus and minus. Okay? Now, of course, for 3 by 3, it's pretty easy because we can always evaluate the 2 by 2, right? If we're doing the process with a 4 by 4, we take this and throw it out in this, and we're left with a 3 by 3, right? Well, how do we do that? Well, we come back to our rule for 3 by 3. We throw this out and do this thing and multiply it by this, and then we throw this out and multiply it by what we got left and multiply it by -1 and then by this and so forth, right?
Yeah.
Okay? So it all still reduces down to the rule for a 2 by 2, determinant of a 2 by 2. It's just a really pretty simple scheme. If you practice, it's easy to learn. Okay? So when we do the determinant of this, it's not hard. Okay? We get the determinant of this, multiplied by this. We get the determinant that we get when we throw this out. That's just this, and multiply by this, and all that, okay? And it's, again, a pretty simple rule that just takes a little practice to get used to. Now for a 10 by 10 matrix, though, it ends up that when you reduce the 10 by 10s to 9 by 9s and then do each 9 by 9, which reduces to 8 by 8s, and do each 8 by 8, you end up having to do like, close to 4 million 2 by 2s. Okay?
That's a lot of factoring.
So what you do is you cheat. Because there's a much easier way to do it that just involves adding multiples of rows to rows. Just like you do solving simultaneous linear equations. And you could actually do it 10 by 10 in 30 minutes, okay? Just by adding rows to get a certain form, okay? And that form is easy to understand, just ones on all the diagonals and zeros everywhere else. Equivalent to solving 10 10 simultaneous equations and 10 unknowns, which is a pain, but manageable. Okay? So right there is about 1/3 of a linear algebra course. So just, take what I said, work out all the implications, and you're in good shape. Okay, well, you're not going to do that. Yeah, some of you probably could if you listened to this video very carefully and took careful notes and worked out everything, because you all are pretty smart. Okay? I wouldn't recommend it, though. Okay? Unless you got a lot of time in your hands. Because it'd be pretty darn challenging. But when you learn it slowly, a little bit at a time, you understand what I'm talking about here, even halfway. It's not that hard. Okay? Doesn't mean linear algebra can't get really hard. People are still doing research in it. The smartest people in the world are still figuring out new questions to ask and answer using linear algebra. Profoundly powerful tool. Very interesting research topics. Okay. So, are you glad you asked about eigenvalues? Don't beat your head against the wall like that. It's going to hurt the wall. Okay. There's a wealth of mathematics here, and everything that I just talked about, other than like doing 10 by 10s and stuff, is something you could easily learn in an hour or two. Okay? And we're going to learn part of it, at least enough to do 3 by 3s.